Welcome back. Today we are going to see another topic on how do we identify the crystal form. A crystal form is a set of crystal faces that are related to each other by symmetry. It's nothing but that particular form, how it is related to the symmetry. That is what how the forms are formed, and it indirectly indicates about the arrangement of atoms in the crystal, and the number of faces in the form mainly depends on the symmetry. That also we know, we have seen in the earlier lectures. And basically the crystal forms are classified into two different types. One is the open form, another one is a closed form. A closed form is a set of crystal classes that are completely enclosed space. That means you can see only one set of faces. Okay, in a open form, we can find more than one set of similar faces, which is not completely enclosed by space. And the open form may be more than one set of faces. Here you can see these prism faces as well as this base are two different sets. Whereas in this closed form, you can see all six faces are similar faces. Okay. So basically this particular entire identification comes in few steps. Mainly we have to check of the shape, how the shapes of the each face is there, and the second one is number of similar faces, Okay, so number of similar faces helps to identify the form, and we can do with symmetry. What symmetry is exist in relation to that particular similar set of faces. And fourth one, we can also use the angles of similar set of faces that helps in recognizing a different set of forms. We will see different types of forms in the continuation of this video. So this is the Pedion, is the set of form, is the open form. Actually it is a only one phase form, where you can see where there is a hemihedral form where the base is single, only one set of face, not a set, it's a only single phase you can find. In hemihedral form generally Pedions are you can see. The another one is Pinacoid. The Pinacoid, we can see it is a open form which two similar faces, and we should know this is parallel faces. This is a two set of two set of faces are parallel faces. Okay, such forms are called Pinacoid. Okay, so here the criteria is number of faces is 2, and it should be symmetry should be parallel. Okay, symmetry should be parallel that both the face should be parallel to each other. And another two set of two face forms, we can say it's a dome. Okay, where these two faces are related to the mirror plane. You can see the symmetry is a mirror plane, and number of faces is 2, and it is an open form. And you can see in this picture that particular mirror plane helps to distinct of these shaded faces. And there is another two-phase form called sphenoids. Sphenoids are again it is a two-phase form. It's an open form, and here the symmetry is related to the two-fold axis. You can see this two-fold axis, this vertical two-fold axis, and you can see these triangles, sphenoids of opposite side. Here these two faces are not parallel, whether in dome or in sphenoid, whereas in pinacoid both are parallel. That is a major distinction to understand. And here, if it is related to the mirror plane, then it is called dome. If it is related to the rotation axis, then it is called sphenoids. So in this way, we could able to distinguish the two faces form in the crystal. And now we can see three or more parallel faces. Parallel faces means it will not intercept in the C axis or any one of the axis. Okay, so it is again it is a open form, and three or more parallel faces will be there. And depends on the symmetry, we can classify different types of prisms. We will see to that. One of such form is a trigonal prism. Here you can see trigonal. That means it's three-phase form, all are parallel. Then only it can called prism. And you can see threefold rotation is major criteria to identify trigonal prism. And there is another form called ditrigonal. Di means two, and here you can see it's only three phases. So each phase will be made as a two different phases. Here this single phase is made as a two phases. So that's what. So 2 into 3 total 6 phases we will get in this ditrigonal prism. You can check the cross section from the top. If you see, it is not hexagon. Okay, and it is not having a six-fold rotation axis. It is having a three-fold axis. So that is a distinction to find ditrigonal prism. And there is another four phases form. It's called rhombic prism. Okay, all are parallel. That is a major criteria to name a prism. And here you can see this shaded faces are parallel to this two-fold axis. In this form, you can see other forms like pinacoid, and from the top pinacoid, and this is the B pinacoid. Okay, so this is a combination of pinacoids and prism, rhombic prism. And in continuation, there is a tetragonal prism. Okay, tetragonal prism means it's a four-sided open form, and it's a parallel to the four-fold rotation axis or four-fold roto-inversion axis also. So then it is called tetragonal prism. That means it is parallel to the C axis. And same thing, whenever there is a die name comes, you have to just multiply the number of faces of that original form. Here the tetragonal prism. So tetragonal prism have four faces, and here 4 into 2, 8 similar faces you will find in tetragonal prism. So in this way, whenever if it is a ditrigonal prism, means trigonal is a 3 into 2, 6. So in this way, the naming helps us to know number of faces also. Similarly, this is another form called hexagonal prism, and hexagonal means 6 similar set of faces that is parallel to six-fold rotation axis. That we know the six-fold rotation axis is the vertical axis in the hexagonal system. And again we use another term called dihexagonal. Hexagonal is a 6 into 2, 12 similar faces will find parallel to the C rotation axis. Though it appears to be a 12-fold rotation symmetry, but it is, since it is a dihexagonal prism, as a result of mirror plane parallel to the six-fold axis. That's what it is, a only six-fold symmetry will get on this form. So in the prism we find parallel faces. In the pyramid we will find all these faces will meet at one point. That is a major distinction to know prism and pyramid. The trigonal pyramids, here it's again it is a three-phase related to the three-fold rotation axis. Again it is a pyramid. When we say pyramid, it should connect at one particular point. Here you can see all these faces are connected at this point. In prism, the faces will not be connected. It will be parallel to any one of the rotation axis. So trigonal, that means trigonal pyramid is a three-phase form, and trigonal means 2 into 3, total 6 similar faces we will get in this particular form, which is connected in a point, and it must have threefold rotation. And there is another form called rhombic pyramid. When we say pyramid, it should connect at one particular point. It is another four-phase symmetry, four-phase form related to the mirror plane. Okay, in this diagram where we have shown as a P, these all are pyramid faces, all connect. If you project all these things, it will be connected at one particular point. So when it is connected, it is a pyramid, and the 4 similar set of faces are called rhombic pyramid. If it is a 3 similar set of faces connecting at a point, means it's a trigonal pyramid. If the 6 similar set of faces connecting at a point, means it is a trigonal pyramid. And here it is connected, it's related to the rotation axis, but here it is connected with the mirror plane. So we have to relate with the symmetry and number of faces, and what is the relationship of this particular single set of faces. If it is parallel to the faces, then it is a prism. If it is all connecting in a particular point, then it is called a pyramid. In continuation of these pyramids, we can see the tetragonal pyramids. Tetragonal pyramids, again it is a 4-phase. Okay, here it is related to the 4-fold axis. Okay, all these faces are connected in a particular point, but it is connected with the 4-fold. So it is a tetragonal. Tetragonal means we can get in the tetragonal class of in tetragonal classes, where 4 faces forms which is related to the 4-fold axis, then it is called tetragonal pyramid. We have to check whether it is a pyramid or prism. First we can count the number of faces, similar faces, and relate with some kind of symmetry, whether it is a connecting or not connecting, or it is parallel, that we have to find. Then we can name that particular form easily. And again I said, when it comes, just you have to multiply with that original form. So 2 into 4, so total 8 similar faces will get. So it is nothing but that original form will be converted into two similar set of faces. So this particular one here, this original trigonal tetragonal pyramids, four it's related to fourfold axis, this will be divided into two similar set of faces, 1 and 2. Okay, so it is called ditetragonal pyramid. And again there is another form called hexagonal pyramid. Is a six similar faces, it's all connecting at one particular point. You can see 6 similar faces and it is connected with a sixfold symmetry, so it is called hexagonal pyramid. And similar way you can see it's a dihexagonal pyramid. So 2 into 6 total 12 similar faces, but it will be connected with in a point and it is having a sixfold symmetry. Now we will get another set of forms called dipyramids. Dipyramids, again it is a closed form, consists of 6 or 8 or 12, 16 and 24 faces. The dipyramids are pyramids that are reflected across the mirror plane. Here the distinction is to find reflected across a mirror plane. That is an important thing we have to observe. Hence this condition is there, so it will be present only the mirror plane perpendicular to the rotation axis, rotation or roto inversion axis. So the rotation axis and the mirror plane perpendicular to that rotation axis where the mirror plane is there, in those classes only these forms will formed. So this is a trigonal tripyramid. So it is a 6 similar faces with related to the threefold axis. In perpendicular to that you will find a mirror plane. So this is a threefold axis and you will find perpendicular to that it is a mirror plane. So here the combination of rotation axis and mirror plane. In the earlier one we saw only whether it is a mirror plane or the rotation axis, but here it should be a combination of these two. Similarly you can see it is a trigonal tripyramid. So we have to multiply this number of faces and the same threefold rotation and perpendicular to one mirror plane will be there. And the rhombic tripyramidal, again it is a 8 similar face form are related to the combination of twofold axis and mirror plane. You can see the twofold rotation axis and the mirror plane give the indication presence of rhombic tripyramidal class. Here you can find two different set of rhombic tripyramidal. One is this set of similar faces is a 1, 2, 3, 4. Similarly the back side also you will find, so 8 similar faces. Similarly we can find this is another set where you will find 4 similar forms, four set of faces. Similarly opposite side, the back side also you will have another 4 faces. So this is the one set and this all other the another set. So we will find two different set of 8 similar faces. So it is a rhombic tripyramidal. It not necessary both should be present. It may be only one will be present, but it should be a 8 similar faces, and it must contain two-fold axis, and perpendicular to that you should have the mirror plane. That is a distinction to define a tripyramidal. In continuation, you can say the tetragonal tripyramidal. Here again it is a eightfold, 8 faces form, and here four-fold axis plus perpendicular to the mirror plane. So you can see here the four-fold axis perpendicular to that there is a mirror plane. Okay, so these two are the major distinction to count. So if it is a 8 similar faces where the four-fold symmetry perpendicular to that it's a mirror plane, then we can say it is a tetragonal tripyramidal. To define a tripyramidal, we must relate that particular similar set of faces with the four-fold axis and a perpendicular to that mirror plane. Similarly, the name suggests 16 similar faces, and the same way it should be a four-fold axis and perpendicular to that mirror plane. Whenever we say it's a di and tetragonal or trigonal, the same set of symmetry operation will be covered here also. So here again it's a hexagonal. So 12 number of faces, and we know it is a six-fold symmetry, and perpendicular to that there is a mirror plane. So here you can see it is a six-fold symmetry, and perpendicular to that you can find a mirror plane. So it's a dihexagonal. Now you may be familiarized with that. It's a 12 into 2, 24 faces you'll get, and this is perpendicular to six-fold symmetry. So other forms are trapezohedron. The trapezohedrons are closed form, maybe of 6, 8, 12 similar faces, which will be of just part of that faces will be at the top and part of the faces will be at the bottom. Okay, so this is a trapezohedron where it's a 3 faces will be at the top and 3 faces will be bottom, where the 6 closed faces are present. Similarly, it is for 8 and 12. And Scalenohedron, it is another closed form where it may be of 12 or 8 identical faces. Scaleno means you can see from this particular face itself, it should be 90 degree at one of the corner of the faces. Generally, this present only where threefold roto-inversion axis perpendicular to the 3 two-fold axis. It present only in such classes. So there is another forms, rhombohedron. Here 6 similar closed form where 3 faces at the top and 3 faces at the bottom side, and this is present only where threefold roto-inversion axes are present and perpendicular to the two-fold axis. So this is generally present only in classes where these point groups 3 bar 2 by m, 3 2 and 3 bar axis, because the necessity is to present threefold axis and perpendicular to that twofold axis also. That is a necessity of finding a rhombohedral tetrahedron. Here you can find number of similar faces and how it is related to the symmetry. The Disphenoids, again it is a closed form, consists of 4 similar faces. It is only present in rhombohedral system, okay, and tetragonal system. So that's all from this particular video, and we'll see in the coming video the other set of forms. Thank you.